Okay, so we're in section 1.2 now. 1.2, this is problem number 1. So this is the first problem. We're on to section 1.2 now. We're going to try to cover one section a day. That's our plan this semester. We'll see if we can keep up with it. So section 1.2, problem number 1. What they're asking me to do first off is they want me to find C. Right there, C. I bet a lot of you already know how to do that, huh? How do we find C in that triangle? Yeah, Pythagorean Theorem, huh? A squared plus b squared is c squared. Exactly. So that's the first thing. So a squared plus b squared is c squared. So that's the Pythagorean Theorem. Remember, when you use the Pythagorean Theorem, the order doesn't really matter as long as you put the c alone, right? That's all that matters. So you can switch the a and the b, in other words. It doesn't matter. But the c must be alone. So hit the buttons on your calculator. 256 plus 900, I think. And so that's like 1156. Is that clean? The square root of 1156 clean? I don't know. I'll hit my calculator here. 34. Oh yeah, it is. It's 34, yeah. So I just rooted it right there at the end. That okay? I just did the square root. Right, that's what you do to turn c squared into regular c, right? You do the root of both sides. That made it 34. So we've got c now. C is 34. And now what they're going to ask me to do is get the 6 trig functions. Good so far? So now we're going to dive into the actual trig functions. In other words, they want the sine of angle theta. They want the cosine of angle theta. They want the tangent. In fact, let me just space these out a little bit more. They want the sine, cosine, and tangent. And then the other 3 also, which we'll talk about in a minute. All right. So this is the beginning here. We're assuming you know nothing about this, but I know probably a lot of you do know something about this. How do we find the sine of theta? Yeah. Opposite the hypotenuse. Yeah. Let me write that out. But again, we're assuming no knowledge, and we're starting from ground floor here. So let me write out, I don't know how you guys memorize it. That's what I'm going to write out. I think it's a nice way to go. Yeah. Sohcahtoa. Sohcahtoa, you can do whatever you want, to help you memorize this. But there's a nice way, a nice saying you might have heard of before. Sohcahtoa. What that stands for is to find this. So this is sine. This is the rule for sine, the rule for cosine, the rule for tangent. The rule for sine is opposite over a hypotenuse. The rule for cosine is adjacent over a hypotenuse, and the rule for tangent is opposite over adjacent. Now, what do I mean by all that opposite hypotenuse? Well, you have to go to the triangle. Let me show you. Which angle are we dealing with? Theta. Where's theta? Right here. So it's from his perspective. They could have given us an angle up there, and then that would have changed our perspective. So you got to, put yourself right here. Here you are. There I am. I'm right there. So you got to put yourself in that perspective. From that perspective, which side is the hypotenuse? Whenever we refer to the hypotenuse, it's always the longest. It's always the C. Hypotenuse. This is the hypotenuse. No matter where you're standing, that is the hypotenuse. Because that's the side across from the right angle. See how the other two hit the right angle? But C, A and B hit the right angle, but C is across from the right angle, isn't it? So that's the hypotenuse. That's the longest side. So whenever we mention H, that's the hypotenuse. That's going to be the 34. So now, what do we mean by opposite and adjacent? Well, so the other two sides, the A and the B, are the opposite and the adjacent, and that depends on your perspective. If you're right here, which is where we are, then which side is adjacent? Means touching you. So the people adjacent to you are the people on your right and your left. They're right next to you. So from this perspective, this angle here, is A or B touching the angle? Well, B, clearly. So which one is not touching but instead is opposite? Well, A. So A is the opposite from the angle theta, and B is the adjacent. Adjacent means your neighbor, right next to you. Now, if the angle was up here, if instead they'd put theta up here, then A would be adjacent to it, and B would be opposite from that perspective, right? That would switch who's adjacent and who's opposite. It's always your perspective for that. The hypotenuse doesn't change, but who's opposite and adjacent will, depending on where you're at in the triangle, right? So if I'm down here, which is where I'm at, then the one opposite me is the A, the one adjacent to me is the B. So when we say the sine is opposite, it means opposite over, it's actually a fraction. It's opposite over hypotenuse. Then the sine is opposite, 16, over the hypotenuse, 34. And then you just reduce that fraction like you would any fraction. Divide by 2. So that'll be 8/17. So the sine of angle theta is 8/17. Good so far? Can you do the cosine? Let me let you go ahead and try to do the cosine. Adjacent over hypotenuse. So cosine adjacent over hypotenuse. So the adjacent side is the 30. The hypotenuse is still the 34. Is that making sense there? So from angle theta, the adjacent side is 30, the hypotenuse is 34. Reduce that like you would any fraction. Divide by 2 top and bottom. 15/17. So the cosine of angle theta is 15/17. Now how about the tangent of angle theta? Why don't you try that one? See if you can get that one. Tangent is opposite over adjacent. And the opposite is the 16 over the 30. And that you can divide by 2 top and bottom again, 8/15. We good with all that? Sine, cosine, and tangent of angle theta. Questions I can answer so far? Then the other thing they want us to do is find the other 3 trig functions, which are just going to be the upside downs, the reciprocals of these 3. So does anybody already know? What's the upside down of sine called? It's cosecant. Yeah, I can write the whole word out. It's abbreviated CSC, but it's cosecant. It's cosecant. Let me kind of get this out of the way here. It's cosecant. And all it means is upside down of sine. So it's hypotenuse. It's just the upside down of that one. So it's just going to be 17. I'm just going to take this answer and flip it upside down. 17/8. It's the reciprocal, the upside down of sine. It's called cosecant. I have to move this too. Next, what's the upside down of cosine? Yeah, that's secant. And so that's h over a. It's the upside down. And so that's good. I'm just going to take the 15/17 and flip it. 17/15. And then the upside down of tangent? Cotangent. So that's a over o. It's just the upside down of 8/15. 15/8. And we're done. That's what they want. They wanted all 6 trig. Those are the 6 trig functions. So what this class is going to be a lot about is dealing with those 6 trig functions. And we found them all. So we started by finding C with Pythagorean Theorem, and then we have the Sohcahtoa definition to help us find the first 3 trig functions, and then flip them to get the other 3. Things I can answer on that? We good? All right. Okay, so let me redraw that triangle a little bigger. They're giving me the triangle here. And they're saying this is little b, little a, little c. And then this point is big A, this point is big C, and this point is big B. So the terminology or the format they're going to use is they're going to make the points, the points be capital letters. So capital A, B, and C are the dots, and the sides are little a, b, and c. That's just the notation they're using. There's no, you don't have to do it that way. That's just how they decided to do it in this book. So, and they're saying little a is 8, and little c is 17. So little a here is 8, little c, which is the hypotenuse, isn't it, is 17. So the first thing they're asking us to find is the missing side. Can you do that? Let me give you a second. See if you can find the little b, the missing side. Use Pythagorean Theorem, right? A squared plus b squared is c squared. Good to there so far. So solve for b, just use your calculator for all these things. What is 17? Is it 289? Okay, so we get to there. We got to solve for b squared, or b eventually. What do we do next to solve for b squared? Yeah, subtract the 64 and then the square root, right? So 225. And then, oh, that's nice. It came out nice. So that's, wait, I know that one. What is that one? Is it 25? 15? 15. So when you square root, it comes out 15. So we got b is 15. Now they want the 6 trig functions from angle theta. Where is angle theta? Then find the 6 values. Oh, for angle B. Okay, I see. Here they go. They're saying angle big B. So they mean right up here. Right, because that's where capital B is. So they want angle big B. So in other words, they want you to now find the sine. Let's start with the sine. The sine of angle B, meaning the angle at point capital B. So find the sine. Remember the Sohcahtoa. Sohcahtoa. So sine is opposite over hypotenuse. Give that a try. So it's from the perspective of the capital B up top there. From his perspective, who's opposite from him and who's the hypotenuse. So from his perspective, the side opposite him is the 15, isn't it? And the hypotenuse is 17. Is that good so far? Does that make sense? And then we need the cosine and the tangent. See if you can get those. Give you a minute. And then just flip them for the other 3 trig functions. The reciprocal functions. Good. So the cosine is adjacent over hypotenuse. So from B's perspective up here, the adjacent side, the side right next to him, is the 8 over the hypotenuse 17. Good. The tangent, I shouldn't just write tangent, it's tangent of something. It's tangent of angle B, is opposite over adjacent. So that's opposite 15 over adjacent 8. You good there? Those three making sense? Questions I can answer, and then we flip them, right? All three of them. So I'll say, okay, so now, what's the upside down of sine? That's called cosecant. The abbreviation, the three-letter abbreviation for cosecant is CSC. Cosecant of B, that's just going to be the upside down of sine, so 17 over 15. And then the secant of B, it's going to be upside down again, 17 over 8. I don't know why this one got messed up there. And the cotangent of B, again, upside down, 8 over 15. And we're done. Okay, so they want the cosine of 60 degrees. So now they're giving me an actual angle, and they're giving me all the sides, so I don't have to mess around with the Pythagorean Theorem. They just want me to use the definition. Let me give you a second to try that out. To find the cosine there. But y'all got that copied down? I need to plug in my little pencil's about to die. So if you've got that copied down, I'm going to pop out the screen for just a second. You guys got that? Give you a second, copy that down, and then work on it. In fact, I could just put it on the board. Give you a second. Okay, so yes, I'm just going to do it right here real quick. Adjacent over hypotenuse from 60 degrees, 1 over 2. This is the adjacent side. That's the hypotenuse side. All right. Okay, so they want cosine on this one of pi over 4. Now, they're giving me a radian angle in there. And so I'm just going to go ahead and change it to degrees. How do we change, what's the easiest way? I mean, we could do the formal pi 180 thing, but I'd rather be a little quicker. I could just put in the 180 for pi, huh? Because pi is 180. You're free to replace pi with 180 degrees anytime you want. So that's cosine of 180 degrees over 4, which is cosine of something, 45? Yeah. 45 degrees. So what they're actually asking, I haven't solved the problem yet, I've just changed the question to be a degree question instead of a radian question, right? And so they're asking me, what's the cosine of 45 degrees? That's what they were saying all along with pi over 4. So what's the cosine of 45 degrees? Well, they're giving me two triangles, and I can choose either one. Well, I choose the one I need, 45 degrees, so 45 is right here. So here's the 40, you just find the 45. You could use this one or that one, it doesn't really matter. It'll work the same either way. So 45 degrees, what's cosine? Well, there's the Sohcahtoa. So cosine again is adjacent over hypotenuse. So from the 45 degree, I'm not even going to use the other triangle at all because I don't have a 60 degree angle or a 30 degree angle, I have a 45. So I'm using this triangle. Cosine is adjacent, the 1, over the hypotenuse, square root of 2. So it's 1 over the square root of 2. And we can't leave the root in the bottom. But so far so good though? Does that make sense what I'm doing so far? Question? Comment?
What did you get from the 180? 4 to 45.
Oh yeah, just divide on your calculator.
Oh, okay.
Just 180 divided by 4 is 45, yeah. Yeah, half of 180 is 90, half again 45. Yeah, just use your calculator on that. Good. Other questions on that one? Not making sense? Good. Okay, and now the square root of 2 on the bottom. Do you remember from your algebra days, how do we get rid of square roots on the bottom of a fraction? Yeah, multiply top and bottom by the root of 2. You remember that kind of? So, because we can never leave roots on the bottom. That's what they say that up here somewhere. Yeah, don't, express the value without a square root in the bottom. So you never leave square roots in the bottom of a fraction. Got to get rid of it. So multiply top and bottom by root 2. 1 times root 2, that's just root 2. No big deal there. On the bottom, what's square root of 2 times square root of 2? Yeah, you're totally right. I could make it square root of 4 first off, but you guys are right. What is the square root of 4? Plain 2. Getting a little scribbly there. So, plain 2. And if you want to go right to there, totally fine. Yeah, square root of 2, square root of 2, the 2 times 2 is 4, and square root of 4 is plain 2, no longer in a root. Right? So what did we do? We got rid of the root from the bottom. There's no more root in the bottom, which is what they asked me to do. Good on that? That's the final answer. Questions on that one? All right. I'll keep moving. There's a lot of information in it. I was looking it over. There's a lot to it. That's why I was a little bit alarmed when my computer wasn't working, because I know I've got a lot to cover in this section. Sine of theta is 21/29, and the cosine of theta is 20/29, and they're going to ask me to, do they want them all or just saying use identities to find? Yeah, they want all the other 4. Okay. Yeah, so they want me to find, they're giving me 2 of the 6 trig functions. They're giving me sine and cosine. No triangles. So they're kind of changing the game a little bit. I don't know if you noticed, right? There's no triangle pictures on this one. They're just giving me sine and cosine. And they're asking me to find the other 4 trig functions. So let's start with tangent. Turns out there's a definition. And again, we're not assuming you know it. So I'll give it to you ground floor, but does anybody happen to already know it? How does tangent relate to sine and cosine? Does anybody know that already?
It's usually the opposite angle and the adjacent angle.
Yeah, tangent is, one way we could, well, let me give you the answer, and then I'll show you why that's the answer. Tangent is just sine divided by cosine. Why? Well, look back at, here's the proof. You don't have to know the proof, you just got to know that. But here's why. Remember Sohcahtoa? So Sohcahtoa, right? So what is sine then? Opposite over hypotenuse, right? So what is cosine? Adjacent over hypotenuse. I'm getting a little scribbly here. Right? So then what if you took sine and you divided it by cosine? Do you see what would happen? Maybe not. Maybe you're thinking, oh, it looks like a big mess to me, Mr. Aaron. Remember from your algebra days what you do with a couple fractions? You could simplify that. There's a couple ways you could go. You could simplify that by, remember dividing is flipping? Do you remember that? This is the same as O over H divided by A over H, right? Because, just over means divide, right? And then what can you do with divide? Remember that? Remember you flip the 1 on the right? Do you remember that perspective from algebra? I'm just proving to you that this is really true. You don't have to do all this. But I don't want to give it to you blindly. I want to show you that it's really true. H over A, so I flip the 1 on the right, and then what will happen? Boom. See what we got? O over A. What's O over A? Tangent. See how I just proved that sine over cosine really is just O over A, or tangent? You see, that's what we call a proof. I just proved it's true. Now, there's easier ways if you're comfortable with other algebra steps. For example, I could have just said, look, I'm going to simplify this by just multiplying h over 1, top and bottom. You can always do that to a fraction, right? As long as you do the same thing to the top and the bottom, you haven't changed it. And what will happen? The h's will cancel. What am I left with? O over a. It's just a quicker way to get to the O over a. Same result. Again, that just proves sine over cosine is O over a, meaning tangent. So I'm just proving a couple of different ways that sine divided by cosine, the h's cancel, and it's just tangent, isn't it? It's just sine O over cosine A, the h's cancel, right here, or this way, however, it's O over A. It's tangent. Tangent's over O over A. So, I'm going to get rid of all that proof. We don't need it, but I want you to see it. So, tangent is just sine over cosine. So you do want to, we're getting like a lot of things that you want to know. You want to have these memorized. So tangent is sine over cosine. So what does that mean? That means I just take sine, 21/29, over cosine, 20/29, like that. That's how I can find tangent. They gave me sine, they gave me cosine. They're asking for tangent. So I just put sine over cosine. And now what would be a quick way? This is what we call a complex fraction from algebra. Fractions over fractions. It's a complex fraction. Remember that? You know, we're doing a lot of algebra. We do. You know, this class, next class, pre-calculus, calculus, a bunch of algebra. You know, this. And so please ask. I'm saying all that to say, I know that you're probably rusty on complex fractions and all the common denominators, all that stuff. Please ask. Everybody is. You're not alone. Don't think, boy, everybody knows algebra perfectly. And then, no, they don't. They don't. And that's my job here, and I'm glad to do it. I want to clean your algebra skills up. That's what you need. You know, really people, as you're going to the higher levels, pre-calc next, then calc, if you're moving that way, people make it or don't make it in that string based on algebra knowledge. It's really all that algebra stuff. It really is. It just gets messier and messier and messier. But it's those same rules. So please ask that stuff. That's the thing that you really need to learn, and that's what I'm really mainly here to do, is make you stronger and stronger and stronger at all those algebra rules. Then you'll be fine. Calculus itself isn't that hard if you're good at algebra. I mean, really good. That's like advanced algebra. You got to really know all the algebra rules by the time you get there. Then it's fine. But if you're weak on algebra, it puts you to death. That's what happens, because it's just so much algebra. So, all right, so remember what do we do with complex fractions? Well, again, I'm just going to do the 29 over 1, 29 over 1, top and bottom. Is that rule making sense? And then it'll cancel. Do you see that that's okay? Because I'm doing same thing top and bottom, right? Whenever you have a fraction, you can do the same thing to the top and bottom, and you're not changing anything, right? So that's okay. That gets rid of the 29s, and we get 21 over 20. And so that's the tangent. Is that good so far? We have to find the other three, but you know how to find the other three, right? Just flip it, flip it, flip it. So cosecant of, I shouldn't just say cosecant, it's cosecant of theta, is, flip it, 29 over 21, and secant of theta, flip it, it's 29 over 20. And cotangent of theta, flip it, 20 over 21. Done for the other three. So all we really did was we said, hey, tangent is sine over cosine. Simplified it, and then flip it, flip it, flip it for the other three. So you do need to memorize these things so you can, maybe this helps, sine and cosecant. Notice how we have this co thing going on. I don't know if you've noticed it. We're going to talk about what it really means in a minute. But we have this co thing going on where we have like sine and cosine, and secant and cosecant, and tangent and cotangent. We'll talk about what that means in a minute, technically. But for now, let's just use it to help us memorize things. Sine, his opposite, has a co in front of it. Cosine, his opposite, doesn't have a co in front of it. So in other words, everybody's opposite switches the co or non-co option. Do you notice that? See the pattern? Right? So because it's easy to get these confused, go, now wait, which one's the upside down of sine? Is it cosecant or is it secant? Which one is it? You'll know tan and cotan. Everybody's got that one. That's obvious. But these can be accidentally confused. Well, just remember, if you're talking sine, he doesn't have a co. So his opposite will have a co. Does that make sense? Everybody's opposite switches the no-co option, doesn't it? So sine goes with cosecant. And who's got the cosine, goes with somebody who doesn't have a secant, right? Just helping you keep those straight. Questions? We good on that one? So they're giving me sine of theta is 3/10. And they want me to use the Pythagorean sine squared plus cosine squared is 1. Yeah, I haven't even told you that's the truth. Sine squared plus cosine squared is 1. Yeah, let me, I don't got time to prove everything today, so we'll just take it blindly and we'll prove it another day. It's true. And there's a good reason for it, but we do that all day long, we won't get through the homework. So we'll just take it blindly right now. Sine squared plus cosine squared is 1. They're giving it to me. And they're telling me the sine is 3/10. So I'm going to take that and plug it in right there. I know you're getting a whole bunch of lingo dumped on you real quick. When they put the 2 power kind of like in the middle, is that weird to look at? That's the same thing as doing that. It just means the whole thing is squared. So that's what they're saying. So it's going to be 3/10 squared plus cosine squared is 1. Good so far. Just plug it in. The sine of theta is 3/10. And so now we just work it out to solve for cosine. So how do we square the 3/10? Square the 3, square the 10, right? 3 times 3 is 9, 10 times 10 is 100. We good to there so far? Bring it up here. So, room, so 9 over 100 plus cosine squared is 1. How do we solve there for cosine? What should I do next? Kind of like solving for an x. Just pretend that whole cosine squared is like x squared, you know? What would I do next to solve for x? Subtract the 9 over 100 fraction thing? Yeah, exactly. So just subtract the 9 over 100. So that's gone. And we get cosine squared equals 1 minus 9 over 100. We good so far? Does that make sense? I just subtracted the 9 over 100 from both sides. Now, how do you do that? Do you remember all your common denominator rules? Again, these are all the things I want to be sure to help you with, because this seems like the small stuff, but it's really the main stuff that if you get all these little rules down, you'll do fine in calculus and pre-calc. That's the main need, is all the little common denominator, complex, all those little algebra rules. They're really the main thing. So you just make that 1 into 100 over 100, right? Because that's just a fancy 1. And then they have a common denominator. Remember all that common denominator stuff? Is that good? Questions like, please speak up if there's anything I can answer. So I'm just changing that 1 into 100 over 100 so that I can now subtract these guys, right? So you subtract them and you get whatever that is, 91 over 100. I'll bring it, kind of running out of room over there. So cosine squared is 91 over 100, like that. Good to there, almost there, right? So now, last thing is how do I turn that into normal cosine? Because that's what they want from me. They want me to find normal cosine. So what do? Yeah, you square root it. And so now, Now here's some algebra rules on square roots. Remember how roots work? When you have a fraction like that, you go ahead and put the root on the top and the bottom. It's doing them both, right? It makes sense, I think. And then, now you can't square root 91. I don't think they want a decimal, do they? Yeah, they want me to leave it a radical. So the square root 91, he just stays in the top. But you can square root 100, as you know, it's 10. So that's our answer. No more. Why did the square root vanish from the bottom? Why is there no more square root on the bottom? Well, because it did the square root on the bottom, huh? Right? You can square root 100, it's 10, but you can't square root 91, so it stays there. So the way square roots work is they try to root something. It tried to root 91, but it couldn't, so it stayed there. It tried to root the 100, it did. Made it 10 and vanished. So when they root something, then they leave, right? So that's why there's no more root in the bottom. So there's our answer. Square root of 91 over 10. Questions I can answer on that one. So what did we do? We just took the formula they gave us. Sine squared plus cosine squared is 1. And I plugged in sine theta is 3/10, squared it, subtracted 900s from both sides, and did the square root. T's. Okay, so sine of 65 degrees, cosecant 65 degrees. So, what's in the middle of, see, these are two trig functions, right? What's in the middle of those two guys? Nothing, which means multiplication, huh? You with me on that? That's times, isn't it? Because there's no plus or minus in the middle. So those are being multiplied, right? Sine of 65 times the cosecant of 65. Any thoughts?
You convert the cosecant.
What do you think the answer is going to be?
It'll be 1.
Everybody see it's 1?
1.
Yeah. Why? Because remember, cosecant is the upside down. If you can just see it's 1, then just write down the answer 1, that's fine. I'll show it more formally. What is cosecant? 1 over sine. Remember, that's the upside down of sine. Remember, sine, cosecant's always his flip. It's 1 over sine. It's his upside down. So that means, really, they're saying sine of 65 times 1 over the sine of 65. And these cancel. And it's just 1.
Are you gonna give us like that cheat sheet to remember?
Yeah, I'm still not sure. I'm still thinking that over. Because it really is important that you memorize these. Even if I give you a 3x5 card and I haven't decided, it is important that you remember. Because what happens to people who don't memorize things is you get to calculus and it's a problem. You really do need to know, not everything, but a pretty good feel for what trig is doing just right instantaneously. Because they give you big, messy stuff, and you need to know it right off the top of your head. So I'll get back to you. All right. I memorize things when I can. But this is worth it. So sine squared. Okay, this is a really tricky one. No, secant squared. This is a really tricky one. Let me just show you this one. Yeah.
Is it tangent? Is it 1 minus the sine 159 over?
You know what I'm going to do? Yeah, there's a couple tricks here. This is pretty tricky. This is like one of the hardest ones. I'm going to break down. Remember what sine, well, remember, and then the opposite is cosecant, right? And then cosine, the opposite is secant. Remember that whole thing? Tangent, the opposite is cotan. What that means then is cosecant is 1 over sine, right? And secant is 1 over cosine. Cotan is 1 over tan, right? You with me on those basic 6 definitions? The right 3 are upside down, right? Okay, so what? Well, that means this secant is really what? 1 over cosine. So this is 1 over cosine squared of 159. You with me so far? Everything else is the same. You keep the 159, keep the squared, but secant squared of 159 is 1 over cosine squared of 159, because cosine and secant are upside downs, right? Okay. And then what's tangent? What did we just learn? Now tangent's this, but I actually don't want to do that. I want to do something else. What did we just learn about tangent? Was it the last problem? No, it was the one before that. What did we learn? No. Was it here? Yeah, what did we learn about tangent right here? What is tangent? Sine over cosine. So you just got to know that cold. You just really got to keep, and what will happen is if you do enough homework, you just keep doing these homeworks, it will. So when you see that tangent, you need to think, oh, that's sine over cosine. That's sine over cosine. So tangent squared, then, is sine squared over cosine squared. Good so far? There's more tricks to come. This is one of the hardest problems. So far, so good. So secant is 1 over cosine. Tangent is sine over cosine. Keep the squares. Keep the 159. Okay, great. I see that. So it looks like it's getting worse. Well, now we have common denominator. See how they both have the same denominator now? That's why this is great. Good so far. I made them one fraction because they have common denominator, right? Same two fractions, same denominator, make them one. Okay, yeah, so what? Well, does anybody recognize what that is? Yeah, I'm sure you don't yet. I know I just gave it to you. Let me help you with what that is. Look back to here. See this right here? That's also super important to know. Sine squared plus cosine squared is 1. We're going to use that 500 times in this course probably. Well, maybe it's exaggeration. Maybe 100 times for sure. 500 times on through calculus for sure. Sine squared plus cosine squared is 1. You just want to know it like you know your name. You just want to know it automatically, instantaneously. Sine squared plus cosine squared is 1. So what? What does that mean? Well, if sine, let me just go s squared, just make it simple. S squared plus c squared is 1. Sine squared plus cosine squared is 1. What that means is, if I subtracted the sine squared from both sides, I would get cosine squared is 1 minus sine squared. So that means this, 1 minus sine squared, is really what? Cosine squared. Am I going too quick? Did you see that? Because of this fundamental identity, sine squared plus cosine squared is 1. If you subtract sine squared plus the cosine squared is 1 minus sine squared. So whenever you see 1 minus sine squared, you want to think cosine squared. It's just going to happen all the time. So I replace all of this with cosine squared, of 159, of course. So that'll become cosine squared of 159. And the bottom hasn't changed. I'm not messing with the bottom. The bottom has been cosine squared of 159 for a while now. So then what does this equal? This is a big fancy 1. We just proved that's a big fancy way to say 1 by using the identities. That makes sense on that? So that's one of the hardest ones. Questions I can answer? So a couple of key theorems. Secant is 1 over cosine, tangent is sine over cosine. And then you got it, when you see 1 minus sine squared, you got to recognize that's cosine squared. That's called the Pythagorean identity. Okay. What's up with the co-things? Why don't we just have like 6 different, we have these 6 trig functions. You're just getting used to them. And what are they so far? What is, trigonometry so far? Well, it's ratios and triangles so far. We'll see some real-life applications. Well, even in this section, we'll see some real-life applications of them. Anyway, getting back to it. So what's with this co-thing? Why don't we just have like 6 different words that are not related? Why do we have 3 pairs that are related with the word co? Why do we have sine and cosine? Tangent and cotangent, secant and cosecant. Notice we have 3 no co-co, no co-co, no co-co pairs. Why? Yeah, it has to do with triangles. Do you know what co means with, right? Co-pilot with. Co also comes from the word complementary. That's where they're really getting it for the co-functions in the trig. Co is coming from the word complementary. Now, anybody remember from geometry, what are complementary angles? they're very nice angles. They say, you're a great angle. No. What are complementary angles? Anybody remember? Supplementary angles, what are those? Supplementary add up to 180. Complementary add up to 90. Yeah, it's two angles that sum add up to equal 90. So it'd be like 60 and 30 or 20 and 70 or whatever. On you go. 10 and 80, you know. Any two angles that make 90. Those are called complementary. Together they make a right angle, in other words. Does that make sense? You could put, if you had like the, I got the 70 and the 20. Together they make a 90, right? They're two angles that together make 90. They make a right angle together. Those are called complementary angles. So what does that mean then? That's what they're referring to when they talk about cofunctions. So for example, if I said the sine of 70, do you know that'll exactly equal the cosine of 20? If you take the complementary angle with the complementary trig function, it's going to be the same value. That's what they're doing with that co word. So that means if you have a co and you take off the co, or if you don't have a co and you put on the co. Either way, if you switch the co option and you do the complementary angle, it's equal. That's what they're saying. So if they give me, let me give some more examples. What if I had the cotangent of 30 degrees? What would that equal? Tangent of 60. Exactly. Or what if I had the secant of 80? What would that equal? Cosecant of 10. Good? So secant, that does not have the co on it. Cosecant, that does. Say, switch. It's like a light switch, right? It's like I'm taking the light switch and I'm just changing it. I'm going co, no co, co, no co. That's all I'm doing, right? I'm just switching the co option, right? So sine, no co. Cosine, put it on. Co, I've got the co. Take it off. Tangent. Cotan, plane tan. Sine, cosine. Secant, no co there. Cosecant. So I'm switching the co option and I'm changing the angle to be whatever is left to make 90. Whenever you do that, they're equal automatically. That's what the cofunctions are all about. So what about their question? Cosecant of 33 degrees. Cosecant, let's do the light switch. Let's switch the co option. He's got the co. Take it off. What function are we talking about? Secant. That's the same thing without the co. Now how do you find the angle? Yeah, just subtract from 90. 90 minus 33, what's that, 67? No, 57. No, 57. 57. So 57. Done. Secant of 57. So you want to choose this option here and put in 57 degrees. Did that make sense? So that's what they mean by the co, no co in the 6 trig functions. Complementary angles. When you switch the co option. All right. Function, it's his copilot. So they're giving me cosine of 3 pi over 7. And they're saying, okay, find a cofunction with the same value. What is that thing going to equal? Well, first off, which trig function, when we switch the co option, cosine will become sine, right? We take off the co in this case, switching the co option. Now, how am I going to do the angle thing, though? 3 pi over 7, they're giving me radians. Radians are always more difficult, huh? If it was degrees, I would subtract from 90. For degrees, right? For degrees, you take 90 minus the angle. That's what we did on this last problem, right? I took 90 minus. That way you find what other one will together add up to 90, right? The co one. So what am I going to do for radians? Who plays the role of 90 degrees in the radian world? What radian angle is 90 degrees? Yeah, you comfortable with that? Getting a little more comfortable with that? Pi over 2. Because remember, pi is like 180. So this is 180 over 2. That's 90, isn't it? That's the way I always think about it. Whenever I see pi, I just think that pi is a 180. That helps me. So that pi is a 180. That's 180 over 2. Yes, indeed, that is 90, isn't it? So that's 90 in the radians. So it's the same thing. You just take pi over 2 minus the angle when you're doing radians, right? So I got to put that angle in right there. So it's pi over 2 minus 3 pi over 7. To find out what angle will work with the 3 pi over 7 to make 90, to make pi over 2. You with me? So I'm subtracting from 90. I'm subtracting from pi over 2. Take my angle, subtract it from pi over 2. That's just like subtracting from 90. It's like if somebody gave me 10 degrees, and I would go, okay, the other one's 80. 90 minus 10, the other one's 80. Right? You just subtract from 90. So if they give me 3 pi over 7, I subtract from pi over 2. Now, how do we do that? Common denominator. This is where I want to slow down and be helpful, because I know it, you think, well, that's algebra. I know, but that's my experience and my years of teaching. This is what gets it's all this little silly stuff. So I want to go slow here with this stuff. So how do you do common denominator? Multiply top and bottom to make the denominators the same, right? So I'm going to go top and bottom of this one by 7, top and bottom of that one by 2. That'll make both denominators 14, right? That good there? Remember all that little stuff? This is stuff where you got to practice your homework, because it really does matter. 7 pi over 14 minus, what's that going to be, 6 pi over 14? Everybody good there? Everybody see what happened there? Now we can subtract them. It's just going to be 1 pi over 14, or really just, you don't need the 1, huh? It's just pi over 14. So it's the sine. So the final answer is sine of pi over 14. Question?
How did you get it? I thought that the opposite, you used the opposite of cos.
Yeah.
Or the,
Right, so yeah, the opposite, the co-no-co thing.
isn't it sec?
Well, what it is, good question. It'd probably be more helpful if I wrote out the whole words. I'm using all the abbreviations. Let me write it out all the way. Cos means cosine. So if you take off the co, you've got sine. That's a good question. I'm sure you're not the only one that has that question. Yeah, I'm using the abbreviations. That's probably hard when you're just getting used to these things. So if I write out the whole word, it's cosine. So when you take off the co, the opposite one is actually sine. Yeah. The secant goes with cosecant. Buddy, you shouldn't come this late to class. I don't know why you're... I'm just kidding. This is Roberto, our tutor. Just a second, I'll call him up. So we good on that question? We all good? Okay. So tangent of 68. You guys have your calculator with you? Try that one. Make sure all your calculators can go degree or radian mode. We'll need both of them at different times. So make sure you're in degree mode. So Roberto, you're going to pass out a survey, right? Anything I need to say right now while you get going on that? So
Let's continue.
okay, just pass out a survey. Just on the hours people are available. Is that what it is?
There you go.
Yeah. Well, let me just say this real quick. Yeah, while he's passing that out. So this is Roberto. He's going to be our ETC tutor this semester, and so he's passing out a survey. So if you know you're never going to go to get tutoring help, please don't fill that out, because Roberto's going to try to shape his hours to meet your needs. So if you know you're not going to be coming for help, then don't turn that in, please. But if you think there's a reasonable chance that you're going to come see Roberto for help, then put down the hours. What is it? It has hours on it, right?
Empty spaces.
Empty.
So
Okay.
You can just fill them in.
Fill in the empty space. Whatever would perhaps work for you to go visit him. He's going to try to shape his hours based on that. All right. So yeah, you guys have your calculator. Make sure you're in the degree radian mode. If you have trouble with that, be glad to help you after class. It's different on every calculator, so I can't really say something to help everybody at once. But one way or the other, well, I don't even know if I'm in the right mode. Yeah, I am.
Make sure you're in radian mode.
This one's a degree.
How do you
Try
get
to
one
answer.
to go on
I try to put the answer or not. So make sure you're in radian.
Round to 4 decimal places, 68.4. Yeah, so this one's degree mode. So I got, for example, 2.5257. How many? They want 4 places. 1, 1. So round to 4 places. 2.5257. Is that coming out okay? They're supposed to check the boxes.
They can check them, they can darken them, I mean.
However,
just let them-
indicate the boxes
Indicate
that
that's
work
a-
for people's
Yeah,
schedule.
that's the schedule that will work for you, you'd be willing to, you'd want to go. to.
Make sure your calculator. I just put in the answer.
Make sure that your calculator is radian.
I just put that, that's not the school.
That's so weird.
Yeah, that's what I looked.
They're wrong. That's so funny. Check your. Roberta, look at that. Look what they're saying. The question is in degrees, notice, and the little box says make sure your calculator's in radian mode. They mix up. That's the box for part 2. They just switched it. Anyway, yeah, it's supposed to be degree mode. That little message is just wrong. That's funny. They're rarely wrong. Math Excel's pretty well combed over. Anyway, you guys getting that okay? Is that good? If you're having trouble, come up after class. Be glad to help you with that. Bless you. Okay, there might be calculators in radian mode. So let's do this one. So cosine of pi over 12. Yeah, so this one, make sure your calculator is in radian mode now. How do we know that's radians? Well, it doesn't have a degree symbol. Plus, it's got the pi. It's really pretty obvious. But anything without the degree symbol, you know, is for sure radian. So change your calculator to radian mode. If you don't know how to do that, come up after class. Be glad to help with that. Go to radian mode. And then cosine. And you need to use the pi button because you got to be accurate on that. So cosine pi over 12. I'm getting 0.9659 like that. Y'all getting that? Did it accept that answer on that one? It did, even though it gave the box thing. Yeah, it was, even though they said radian mode. That's so funny. Is that coming out? Question?
So radians when it has the pi, degrees when it has degrees.
Yeah, good question. So degrees is when it has the degree symbol. It doesn't have to have a pi to be radians. Let me show you. For example, what if they had said this, guys? Let me ask this question. What if they'd said find the cosine of 1/12? Would that be degrees or radians? There's no pi there, but it's still radians. Why? Because there's no degree symbol. That's the rule. Degree symbol, no degree symbol. If it's got a degree symbol, it's degrees. If it doesn't have a degree symbol, whether it has a pi or not, it's radians. Does that make sense? Yeah, so don't become dependent on the pi. The pi doesn't have to be there. It's all about the degree symbol. If it's got the degree symbol, it's degrees. If it doesn't have the degree symbol, it's not degrees. It's radians. So y'all able to get that? All right, so I'm going to need to stop there. So we did not finish 1-2. Just 1-1. I'll update Math Excel. Only 1-1 will be due on Monday. I'm going to let Roberto have the floor for a minute. So hold on, we're not out of here yet. Roberto needs to talk, so I'll let him do that.
Sure. So, my name is Roberto.